Electricity is a flow of charged particles. These particles originate in the atom. If you have ever studied the atom, you will know that an atom has a compact center called the nucleus. The nucleus contains two types of particles: protons, which have a positive electric charge, and neutrons, which have no electric charge. Small charged particles called electrons exist outside of the nucleus. Electrons have a negative charge and they are attracted to the positively charged protons. The electrons move in high-speed orbits around the nucleus, held close to the nucleus by the strong force of attraction from the protons. You can witness this force by rubbing a balloon on fabric, creating an imbalance of electrons and protons. Small pieces of paper will stand up and jump to the negatively charged balloon. Scientists call this static electricity because the charge doesn't move, it stays on the balloon. Two negatively charged balloons repel one another. The like charges on each balloon repel. This force can cause electrons to move from one place to another. When electrons flow between 2 points, we call this electricity. One of the most dramatic effects of electricity is a lightning strike. Electrically charged clouds release their charge in an explosive flash. A powerful demonstration of electricity. To use electricity, we need to find a way to safely contain and control this flow of charged particles. That is what a battery cell does. A battery is a chemical device capable of converting stored chemical energy into electrical energy. As you know, batteries have two terminals or ends labeled plus and minus. This reflects the negative and positive charges on electrons and protons. The chemistry of a battery creates a force that moves electrons out of the metal plate on the negative end and attracts them to the metal bump on the positive end. Electrons will start to move from minus to plus if the right kind of material is connected to the battery. Materials that allow electricity to travel through them are called conductors. Most metals are good conductors of electricity. Copper is the most common metal used in wires. In this animation, a conductor is connected to each terminal of a battery. Electrons start to move, traveling from the negative terminal towards the positive terminal. This is electricity. The electrons actually move from atom to atom as they travel through the conductor. This is a safety warning. Never connect a short metal wire between the terminals of a battery. This is a short circuit. The wire will get hot, you might burn yourself, and the battery will quickly lose its energy. Have you noticed the letter V on the side of a battery? This represents volts. Volts, or voltage, is a measure of the force moving the electrons. A AA battery is usually 1.5 volts. This is a low voltage, and that is why it is safe to handle a AA battery. Higher voltages are dangerous. Never experiment with anything that plugs into a wall outlet. Wall outlet voltages range from 120 volts to 240 volts. Extremely dangerous.